Advanced Math, Set 106, Translations of Conic Sections, Equations of the Ellipse and Equations of the Hyperbola. So we're going to start out looking at a circle. And we know the equation of a circle is x squared plus y squared equals r squared. And this is for a circle that is centered at 0, 0, centered at the origin. If we wrote it as x minus h quantity squared plus y minus k quantity squared equals r squared, we know that it has been translated. It's translated h units to the right and k units up. We're going to use similar translations with this lesson using ellipses and hyperbolas. So we'll start with the ellipse. This is the standard form of an ellipse that's centered at the origin. And if we just have x minus h quantity squared and y minus k quantity squared, then it's the same thing as the circle. It's translated h units to the right and k units up. Same thing for a hyperbola, standard form, and then translated to the right and up. So we'll do some examples. So this is an example of an ellipse that's centered at the origin. The major axis is horizontal and it's 8 units long. The minor axis is vertical and it's 6 units long. So we'll just do a little bit of alteration here. This is an example of an ellipse that's exactly the same as the one on the left, except for the fact that it's been translated, and so it's now centered at 3, negative 4. So it's been shifted to the right 3 and down 4. Okay, the standard form is what we see at the top, and you'll also use a form that's called the general form, and it is written in this form: ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So if we take that ellipse that we were looking at before, and we want to turn it into the general form, what you want to do is multiply to get rid of the denominators. So we're going to multiply every term by 16 and every term by 9. That way in the first term the 16s will cancel, in the second term the 9s will cancel. So you end up with 9 times the quantity x squared minus 6x plus 9 plus 16 times the quantity y squared plus 8y plus 16, and all of that is equal to 144. Now we can distribute, so we get 9x squared minus 54x plus 81 plus 16y squared plus 128y plus 256 equals 144. Now we just need to reorder. So we take the x squareds first, so 9x squared. Any xy would come next, but there are no xy's. Now we'll do 16y squared, and then we look for x's, and then the y's, and then finally the constant term, and it's set equal to 0. So you'll notice that we have A, C, D, E, and F, but B is missing. B is equal to 0 in this case, and for conic sections, in almost all cases that is going to be the case. So we'll do an example. Describe the ellipse 3x squared plus 2y squared minus 6x plus 8y plus 5 equals 0. Begin by writing the equation in standard form. So this time we're starting with the general form and we're going to work our way backwards to get to standard form. So the first thing that you want to do is rearrange so that we've got the x's paired together and the y's paired together, and then the constant term goes on the other side of the equal sign. From here you can see that the x's we can factor out a 3, and on the y's we can factor out a 2, and that's all equal to negative 5 still. And we will want to complete the square, so half of negative 2 squared is going to be 1, half of 4 squared will be 4, and you have to be careful because you're not adding 1 and 4 on the other side, but you're adding 1 times 3 and 2 times 4, so it will balance out. So from here we write it as the product of squares, so 3 times x minus 1 quantity squared plus 2 times y plus 2 quantity squared equals 6. And the last step is to make that constant term equal to 1, so we'll divide everything by 6. So we end up with x minus 1 quantity squared over 2 plus y plus 2 quantity squared over 3 equals 1. Now if you remember, the bottom is going to need to be squared. So 2 is actually the square root of 2 squared, and 3 is the square root of 3 squared, equals 1. So that's the standard form. Now we use this information to describe the ellipse. So this is an ellipse that's centered at 1, negative 2. The major axis is vertical, and it's 2 square roots of 3 units long, and the minor axis is horizontal, 2 square roots of 2 units long. Okay, now we're going to talk about hyperbolas. So hyperbolas are very similar to ellipses. The only difference is that minus sign in the middle. So this is an example of a hyperbola that's centered at the origin. And we know that the vertices are positive and negative 3 and 0, 3, 0. The asymptote rectangle is going to be 6 units wide and 8 units long, or high, I should say. And then we're going to take the same equation and we're going to shift it. So this is the same hyperbola, it's just shifted now. The center is now negative 2, 3. So if we wanted to take this and write it in general form, we multiply every term by 9 and 16. The 9's will cancel out and the 16's will cancel out of the second term. So we end up with 16 times the quantity x squared plus 4x plus 4 minus 9 times the quantity y squared minus 6y plus 9, all equal to 144. We can distribute, so we get 16x squared plus 64x plus 64 minus 9y squared plus 54y minus 81 equals 144. And now we just need to reorder. So you do the x squared and the y squared, and then the x and the y, and then finally your constant term. And that again is the general form where the standard form is up above. Okay, we'll do one more example. This one says complete the square twice to change the form of 9x squared minus 4y squared plus 18x minus 16y minus 43 equals 0 to the standard form. Graph the equation, find the equation of the asymptotes. So kind of a lot of stuff that it's asking us to do here. So the first thing we're going to do is we're going to group the x's together and group the y's together and then put the constant term on the other side of the equal sign. We'll factor now, so factor out a 9 from the front, or the first term, and factor out a negative 4 from the second term. It's all equal to 43. Now we need to complete the square, so half of 2 squared is 1, half of 4 squared is 4. From here, we're going to add 9, and then we will subtract 16, and then we're going to write it as our square. So 9 times x plus 1 quantity squared minus 4 times y plus 2 quantity squared equals 36. We'll divide everything by 36. So we end up with x plus 1 quantity squared over 4 minus y plus 2 quantity squared over 9 equals 1. And then the last step, x plus 1 quantity squared over 2 squared minus y plus 2 quantity squared over 3 squared equals 1. Now we need to graph this. So the easiest way to graph it is to ignore the translations at first and just look at the hyperbola that we would be looking at without the translations. So we know that it's going to be 2 units wide and 3 units tall. And we'll draw the asymptotes and then draw the ellipse, or excuse me, the hyperbola. So from here, we can take that graph of the hyperbola and then we know we need to shift it. We need to shift it 1 to the left and shift it 2 up, or excuse me, 1 to the left and 2 down. And so the center the center of those asymptotes is going to be at the point -1, -2. From here you can see that the axis is denoted in black, and we can identify a couple of key points. So the point 1, 1 is the upper right hand corner of our rectangle, and the point 1, -5 is the lower right hand corner. So we need to figure out the equations of these two lines of the asymptotes. So I can see that my slope is 3/2 for the first line, and I can use the point 1, 1 to plug it in. So y equals mx plus b. We use the point 1, 1, and the slope is 3/2 to figure out that b is equal to -1/2. So our equation is going to be y equals 3/2 x minus 1/2. And then we'll do the same thing with the other line. So the slope is -3/2 in this case. It goes through the point 1, -5. So -5 equals -3/2 times 1 plus b. So our slope is going to be -7/2. The equation is -3/2 x minus 7/2.